Welcome. Today is Tuesday, December 15th. We are 10 days away from Christmas and about a week away from Christmas break. So hopefully this video finds you in good health. Here we go. For self-start today, students are either working on the worksheet from yesterday if they didn't have a chance to finish it, or doing these three problems. So first thing, draw my fence. What I do to one side, I do to the other side. So we need to get rid of the constant, or the term over on this side that does not have a variable with it, which is that 18. So the inverse operation, or the opposite of adding 18, would be to subtract 18. So I'm going to do that to both sides. Those cancel out. So I'm going to bring down my 3z on this side. And 27 minus 18 is going to give me 9. So now I have 3z equals 9. When the 3 and the z are connected like this, there's nothing between them. That means to multiply, the opposite being divide. So I'm going to divide both sides by 3, and I get an answer of z equals 3. Draw my fence. The inverse operation, or opposite of subtracting 2, would be to add 2. So I'm going to do that to both sides. So that gives me 1/2 m on this side, and 6 plus 2 is 8 on this side. So this 1/2 and this m, again, there's nothing between them, so that means to multiply. So I'm going to divide both sides by 1/2. That's going to give me an m on this side, and this is going to give me 16 on this side. Make sure to use your calculator if you don't believe me. Last one, draw our fence. Opposite of adding 16 would be to subtract 16 from both sides. Bring down my negative 6x. 58 minus 16 is going to give me 42. Again, that negative 6 and that x are connected through multiplication, so the opposite would be to divide. I'm going to divide both sides by negative 6. And my answer comes back as a negative 7. For those people that are quarantined, that just came back, you have until Monday. If you're still out on quarantine, you have 1 week from when you return back to school to have your work turned in for full credits. So when you get back, if you need any of the papers, just make sure to ask me for it. Originally, we were going to do a feedback today on two-step equations, but I'm actually going to push that back one day. We're going to do that one tomorrow. And please try your best to be here this week. Specifically, we're going to be looking at Friday, Monday, and Tuesday. We're just going to kind of take a little bit of a poll. That's just going to help me figure out what exactly we're going to be doing this week. So we've done the self-start. Today we are going to be focused on two-step real-life problems, so the real-world problems. When we're setting up the real-world problems, we've been doing an awful lot of this over the course of this year. Watch for some keywords. These keywords help us set up our problems to solve. So each means to multiply, every means multiply, per means divide, and typically means to add, is, this might be a new one, is typically means equals. Less, that means to subtract. More means to add. Times, well, obviously that means to multiply. Plus means to add. So watch for keywords like those. So 7 more than 2 times the number is 31. So the first question I need to ask on this type of problem is, what keywords do I see to help me out? Well, I see more, and so I know I'm going to be adding. I see times, so I know I'm going to be multiplying. And I see the word is, which means equals. So 7 more than means I'm going to be adding 7. 2 times a number means I'm going to multiply 2 by a number. But it doesn't say what number I'm going to be multiplying by. So what do we do in math for things we don't know? Well, we're going to use a variable. Doesn't matter what variable you want to use. So I'm just going to use x. Is 31 means equals 31. So when we set it up, I always like to put my equal signs first and then my total. That just kind of helps me out. So if I come back up here, I'm adding 7, so I know I'm going to be adding 7. 2 times the number, 2 times the number. Again, we don't know what number, so that's when we use our x. So 2 times x. And there is our two-step problem to solve. 2x plus 7 equals 31. When I solve it, I draw my fence, subtract 7 from both sides, bring down my 2x. 31 minus 7 is 24. I'm going to divide both sides by 2, and I get x equals 12. There we go. So here's our next problem. 15 less, there's the keyword, then 10 times, there's another one, times, the number is 75. So again, if I look at those keywords, that helps me set up my problem. I like to always set up my equal sign first. So is 75, that's going to be equal 75. So that can eliminate that one. That will eliminate that one. And now I can start setting up my problem. 15 less means I'm going to be subtracting 15. 10 times a number. We don't know what number, so there's my variable. So that would be my equation. So the correct answer would be this one right there. To solve it, I'm going to add 15. That gives me 10x left on this side, and 75 plus 15 is 90. Divide both sides by 10, and I come up with an answer of x equals 9. Now when we start dealing with more of the real life stuff rather than just word problems, remember we did this a while back where we figure out what we know, what we don't know, and then write an equation. You bought 4 gift cards and a book for $5. You spent a total of $25. How much was each gift card? So what do we know? We know we bought 4 gift cards. Again, I'm sorry that this is so sloppy. I'm just trying to use a mouse. I bought a book. The book was $5. I know my total, which is 25. What do we not know? Well, the question says how much was each gift card. So we don't know the cost per gift card. I'm just going to put per card. What variable do we want to use? I'm just going to use x. Now it's time to set up my equation. Again, I always like to put my total first, just because that makes it easy for me. I got 4 gift cards and a book. That word "and" means I'm going to be adding. So I'm going to get 4 gift cards and a book, which was $5. But we don't know how much each gift card was. So am I going to put my variable with the number of gift cards I bought or with the book? Well, if we don't know the cost per card, that has nothing to do with the book. So we're going to put it with the number of gift cards I bought. So that right there is my equation. 331 students went to a movie for super activity. 6 buses were filled and 7 students traveled in cars. How many students were in each bus? Well, what do we know? We know that we used 6 buses. And 7 people went in cars. So 7 in cars. We know my total. There was a total of 331 students that went. What do we not know? We don't know how many students were in each bus. Okay, I'm just going to use the variable b for bus. An equation, again, I like to put my total first. When I go back and read it again, I see 6 buses were filled and, so I know I'm going to be adding. So 6 buses were filled and 7 went in cars. What do we not know? We don't know students per bus. So I'm going to put my variable with the buses, the 6 buses, because it has nothing to do with the cars. And there is my problem. Okay, next one. Mark rents a bouncy house for $14 plus $3 per hour. He spent $20 overall. How many hours did she rent the bouncy house? What do we know? Well, we know it was $14 for the bouncy house. We know it was $3 for each hour. Again, I'm sorry about my handwriting. I know my total is $20. What do we not know? We don't know how many hours they rent. So we don't know the number of hours. What variable did we use? We'll use h for hours. That's fine. Equation, put my total first. My total is 20. I see a keyword right there, plus. So that means I'm going to be adding. So now we've got $14 and $3 each hour. So I'm going to put my h with my 3, and there's my equation. I'm going to go ahead and stop there. If you have any questions, contact your teacher, email or Canvas. Hopefully we see you guys back soon enough, and we'll talk to you later.